So today we have a really fun problem to do. Now, whenever someone says in relation to mathematics that we have a fun problem, that always means it's a little bit more difficult, but it is very interesting. It's another problem from this book, Calculus, by Michael Spivak, that I introduced in my last video. And instead of problem 2, well, it's actually part of, it's a subset of problem 1, the big chapter. It's actually a subset of problem 1, so when I said it was problem 2 in the book in my last video, I actually meant it's problem 1 part 2. It's the second part to the problem, but today we're going to do the fourth part to the problem, which is going to be a more abstract problem, and I always think those are the most fun. So let's jump right in. Now, in this problem, we have the limit as x approaches y of quantity x to the n minus y to the n, all divided by the quantity of x minus y. Now, while this problem looks more abstract, more difficult, I can assure you that it's not too much more difficult than the problem in my previous video. And the reason it appears more difficult is because there are letters instead of numbers, but we're going to use the same technique. We're going to factor out x minus y in the numerator and divide it by the denominator, because you can clearly see as x approaches y, well, we can't just plug y in because you have x minus x, or I mean y minus y, and then you have 0, so that doesn't work. Now, what we have as a result of this, and I'm going to prove it in just a moment, we have the limit of as x approaches y. And the great thing about this proof, or this doing this problem, is that once we solve it, we can get it for we can use this for all problems of this form. So we have x to the n minus 1 plus x to the n minus 2 multiplied by y, and again I'll explain all of this in just a moment. Plus, and then we have x to the y minus x multiplied by y to the n minus 2. Apologize for running out of space. Y to the n minus 1. Now, at first this seems, this seems random, and it's not quite clear how you get to there, but we'll prove that if you multiply x minus y by this whole thing, then you can go back to the original form. And again, it's just like how we did in the previous video, except in the previous video it was a little bit easier to see since we were using real numbers. So you have we have this whole quadratic, and we have the quantity x minus y, which is being multiplied by it. So x minus y multiplied by, I'll denote this as z, just for clarification, just so that I don't have to write out all of that. We have x minus y multiplied by z, where z is everything inside here. And so first we multiply x by every other term, just basic algebra again. So x multiplied by x to the n minus 1 is clearly x to the n. Then you do it x to the n minus 2 multiplied by y, and that's because you're multiplying y by every other term. So for y, when we start, well, y here, y multiplied by the y to the n minus 1 is y. And we can see multiplying y multiplied by y to the n minus 1 is y to the n. You multiply y by this, you have y to the n minus 2, and of course the negative sign flips positive. And then you work your way back, all the way back to x to the n minus 1, and you do the same thing for x, except for x you start here. And again, I'm doing this for visual purposes, but x multiplied by this would be x to the n minus 1, and you keep going. And you can see that this, it might be more difficult to see here, but this is the factored form. But if you multiply this out, then you would have first x to the n multiplied by, so it would be x to the n squared, and then you would have it all multiplied out. So this factorization makes sense. Now, once we have this factorization, we can do the same thing we did again in the previous problem, and just plug in just plug in the answer. So we plug in y, and what we get is y to the n minus 1. We get y to the n minus 1 plus y to the n minus 1, because here we have x to the n minus 2 multiplied by y, so y to the n minus 2 multiplied by y is y to the n minus 1. And then we just have that. We have this sequence going on. And in mathematics, when we have this dot, 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 that just means the sequence continues. Usually that's there after there's some type of visible pattern. So here we can see the visible pattern, then y to the... Anyway, and then you go all the way down to well, y to the n minus 1. Because if you see the way it works, then once you replace x with y, then it's always going to be y to the n minus 1 because of the way, for example, here you have y multiplied by y times n to minus 2, that's y to the n minus 1. You just have that throughout the entire sequence, and you can test that on your own if you don't believe me. So then we have the answer. We can just denote it as n because it's n times. You have n of y to the n minus 1. So n y to the n minus 1. And here we have our limit. And this is true for all problems of this form. So we could replace we could replace y with numbers, we could replace n with numbers, and then plug it into this here, and then you'll get your answer for the selected problem.